All right, welcome back, everybody. For those of you playing along at home, this is I forgot to record while I was going over the homework. So for everybody watching along at home, I'm just going to click and scroll through the homework assignment so that you can see the answers. And then message me if you have any questions or anything like that. I can help you through it. So again, pause where you need to. I'm just going to scroll through the homework key. Watch out for number 36. I kind of explained this to the in-person class. Our tendency is to try to set this equal to 0, but this is the one with the tightrope walker, and we don't want it to equal 0. We want it to equal 11. We don't want him to hit the ground. We want him to hit the net safely. And based on the diagram in the book, the net was at 11 feet. So you set it equal to 11, and then basically just solve for t. And then here's 46 and 47. Okay. All right, and we're back. Sorry, folks. Okay, so I kind of wanted to talk about sections 5.4, 5.5, and 5.6. And this is kind of like a review of almost the entire chapter 5. Maybe we could call this 5.3 to 5.6, a little bit of a review. But basically what I wanted to talk about here is that there's all different types of solving quadratics. We've been spending sections 5.3, 5.4, 5.5, 5.6, 4 sections worth on solving quadratics in a variety of different ways. I don't want to say that this is an exhaustive list because there are different ways to solve quadratics that we will not learn, more advanced methods. But this is just the method that will kind of get us through. We've got methods that will work all the time. We've got methods that will work some of the time. We've got methods that will work easier for some types of quadratics, and it just kind of lends itself. So let's talk about each one. The first method that we have is graphing. Now, I will tell you this right now. The test on Monday is a red calculator test. So you will not be able to use your graphing calculator. It's just one of those small red calculator tests. So I will not be asking you to solve by graphing, but that is a method that we talked about. We talked about it really early on. So graphing, the problem with graphing is that if I go to my calculator and actually figure out what the zeros are, it gives me an approximate value. It gives me a rounded decimal answer, which is never exact, unless it's an integer or a rational number, something like that. Now, the next method that we talked about, this is more getting into section 5.3, is factoring. When would I use that? Well, factoring is easiest when you have no number out front. And it actually does factor, right? Our first line of defense is always trying to factor. If we can factor it down, life is good, right? If we can factor it down, life is good. We can factor it, set them both equal to 0, and then solve. Remember the difference between problems where I just say factor and then the problems where I say solve. The problems where I say solve, I want you to get it down to x equals. The problems where I just say factor, I just want you to get it into its factored terms. The next method we talked about is solving by square roots. We're moving into more of section 5.4. Solving by square roots. This is when we have no b term. Okay, the variable side of the equation is perfect square. That's when it's best use. A lot of times if I've got no b term, if I've got a square, binomial squared, and just a number on the other side, I've got no b term, I easily solve for x. Those are the times when I want to use square roots, when I can easily just solve for x or solve for the variable. There's no more b value. And then we talked about completing the square. Now, people are always like, oh, completing the square is so hard. I'll tell you what, guys, yes, there are times when it's difficult. There are definitely times when it's difficult. The issue is, people think it's more difficult because there are times when you have to work with fractions, and people hate fractions. But, take, for example, the one that's on the board right there. That's a very easy completing the square problem, right? It lends itself to completing the square. It doesn't factor. So it lends itself to completing the square because b is even, and it's a whole number on the other side, and there's no a value. Like x squared plus 6x equals 10. Oh, perfect. Add 9 to both sides. We've got 19 on the right side. Square root 19, that's a prime number, so it's just going to be left with the square root of 19. So it's -3 plus or minus the square root of 19. Right? So in that case, it might be easier to complete the square rather than try to use the quadratic formula. And then we have the quadratic formula, right? The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you memorize that. Make sure that's in your brain. But for example, like this last one here, 5x squared minus 7x minus 8. I would hate to complete the square with that one because I would have to divide through by 5. I would have to take half of negative 7/5. Yikes, no thank you. But what I can do there is use the quadratic formula. Opposite of b, positive 7, plus or minus the square root of b squared minus 4ac all over 2 times a. Chip away at the square root, keep going inside the square root, solve, and then reduce down the square root as needed. See, this one is a very easy quadratic formula problem because the numbers, they're big, and they end up being a non-perfect square, right? Or a number that doesn't even reduce easily. Yeah, it's almost like the more complicated the problem, the easier it is, the more it lends itself to doing the quadratic formula. Okay? The numbers are large or complicated, the expression does not factor easily. I would add on to this list when it's easy to use it, or when it lends itself to using this word problems. I would, in general, if I'm asked to solve a quadratic formula and it's a word problem, I'm asked to solve the quadratic equation and it's a word problem, I'm using the quadratic formula almost every single time. Okay, so here's what I want you guys to do. And I'm going to eliminate, you do not have to graph this one. I would like you to solve this by the quadratic formula factoring, and then I want you to attempt to complete the square. Okay, I want you to solve this in 3 different ways. By the end of what you factor, you should know the answers. Okay, by the time you get done with factoring, you should know the zeros. So you should know what you get out in the end for the quadratic formula. I'll give you a bunch of time to work on this. Okay. In a couple minutes, I'll go through the factoring, and then I'll give you a couple more minutes, and then I'll go through the quadratic formula, and then I'll give you a couple more minutes, and then we'll go through the completing the square. So solve that by factor. Okay, I'm going to start by factoring here. What do we find the factors of? What do we find the factors of? Is this a hard type factoring or an easy type factoring? Hard type, because I've got an A out front. Right? I've got an A out front, so I know that this is a hard type. I take A times C. This is what I called in the video as the master product method. 6 times, or the factor by rewrite method, 6 times negative 20 is negative 120. Okay, now I don't know the factors of a negative 120 off the top of my head. Well, what I'm going to do is I'm going to think about, okay, they've got to make a difference of negative 7. Okay, so they're 7 units apart, basically, right? So let's try to think of some. 120 divided by, well, what about 10? Okay, so those are only 2 units apart, so that's not going to be good enough. 120, you got to go smaller. So 120 divided by 8. Ah, there we are. 8 times 15. Those are 7 units apart, right? The bigger one's got to be negative because this has to be a negative 7. So negative 15 times positive 8. Negative 15 times positive 8 is negative 120. Negative 15 plus 8 is negative 7. So what I can do here is rewrite my middle term and say 6x squared minus 15x plus 8x minus 20. I factor by grouping now. Remember, what did I do there? I just left my first term and my last term the same. I rewrote my middle term into those 2 factors. And now I factor by grouping. I factor out the first term, which is a 3x, leaving us a 2x minus 5. I factor a 4 out of the second set, leaving a 2x minus 5. Remember, that's the goal here. These pieces underneath the pieces inside the parentheses should be exactly the same. So that becomes one of my first factors, 2x minus 5. The other factor is a 3x plus 4. Okay, if I wanted to solve this, I got to get x equal. So I set it equal to 0. I say 2x minus 5 equals 0. And then 3x plus 4 equals 0. I add the 5, divide by 2, 5 halves, or 2.5. I subtract the 4, divide by 3, negative 4 thirds, or negative 1.3 repeating. Okay. Go ahead and try to do the quadratic formula. We know the answers are 2.5 and negative 4 thirds. Go ahead and try to do the quadratic formula. We decided at one point when we eventually decided to make this a right calculator test rather than a graphing calculator test. It was when I can't remember, a couple of years back now. A student was like, "Look, I found this on my calculator," and it was called Quad Form Solver. Right? And it was a quadratic formula solver. I don't know where they found it. I don't know how they got it in the calculators, but we didn't want to run the risk of that. Literally, it just, if you hit enter on the program, it said A value, you entered it, B value, you entered it, C value, you entered it, and it spit out the exact answer for the quadratic formula. Like with the plus and minus and everything. Like, it was like, wow, that's cool. Unfortunately, we can't use that anymore. A is 6, B is negative 7, C is negative 20. The opposite of B plus or minus the square root of B squared minus 4C. There you go. Notice that I actually take B squared. I don't know what it is. I always like to do that. Notice that is a positive 49, people. Negative 7 squared is a positive 49. Make sure you're getting a positive number right there. So I go to my calculator and I chip away underneath. 49 minus 4 times 6 times negative 20. So that's underneath my radical. Let's see if that's a perfect square. Oh, it's a perfect square. Look at that. 529 is 23. Not negative 7, positive 7, excuse me. Positive 7 plus or minus. It was the square root of 529, but that is 7 plus or minus 23 all over 12. Square root of 529 is 23. So that means my two solutions are x is equal to 7 plus 23 over 12, or x is equal to 7 minus 23 over 12. So 7 plus 23, that's 30 over 12. So 30 over 12 gets us 2.5, or as a fraction, 5 halves, which makes sense. 5 halves or 2.5. I'm guessing this one comes out to be negative 4/3 or negative 1.3 repeating, right? 7 minus 23 divided by 12. Yep. Oh, no, divided by 12. Negative 16 divided by 12. Yeah, there it is. Negative 4/3 or negative 1.3 repeating. All right, I'm not going to make you do completing the square by yourself. I just want to show you, I want you to appreciate factoring and the quadratic formula, because when we go to complete this square, this is going to be messy. This is going to be gross. It's going to be nasty. Eek. Why do I say that? Well, I start by moving my 20 over to the other side. So 6x squared minus 7x is equal to positive 20. And now, what do I have to divide through by? 6. Eek. No, thank you. Yikes. Okay, I've got to complete this. Okay. I'm not going to like it, but I'll do it. So I've got x squared minus 7/6x is equal to 26. I'm going to reduce that down. Let's make that 10 thirds. 10 thirds. Okay? All right, so let's take some preliminary work here. I've got to take 7/6. I've got to take half of it, which is 7/12, and then I'm going to square it. Oh, sorry, negative 7/6 and negative 7/12. And then I'm going to square it. So I'm going to add to both sides, square numerator and denominator, 49 144ths. 49 144ths. Now, I factor the left side, but remember that it factors into x minus 7/12 squared. And on the right side, okay, I've got 10 thirds plus 49 144ths. 10 thirds plus 49 144ths. So let's get common denominators here. Let's try to make them both out of 144. What do I multiply 3 by to make it look like 144? Well, 144 divided by 3 is 48. Sweet. It's nice and easy. I took 3 times 48 to get 144. I'll take 10 times 48 to get 480. Right? So what did I do there? I multiplied top and bottom by 48 to get common denominators. So on the right side, I have this 480 plus, I'll write it out here, 480 over 144 plus 49 over 144. So I've got x minus 7/12 squared is equal to 480 plus 49. Ooh, this is a number that I've seen before. 529. Ooh, interesting. 529 over 144. 529 over 144. And now I square root it. The square root of 529, that was 23, right? 23 over 12, and don't forget the plus or minus, right? Square root of 144 is 12. So it's x minus 7/12. is equal to plus or minus 23 twelfths. So x is equal to 7 twelfths plus or minus 23 twelfths. And at this point, I go and I actually figure it out. I take 7 plus 23 over 12. That's 30 twelfths. That sounds familiar as well. X equals 2.5 or 5 halves. And then I would take 7 minus 23 over 12. Negative 1.3 or negative 4/3. Yikes. Ooh. Don't worry. When I force you to do the completing the square, it is not going to be anywhere near as difficult as that. I promise you. All right. But those are the different methods that I could ask you to do on the test. All right, so at this point, for the folks playing along at home, I'm going to pass out the practice test, which I've linked into the assignment. It's just 1 page, 13 questions, so no, I didn't mess up scanning it. It is not two-sided. The only other thing I would add to this is I'm going to tell my students in person here, on the back of this, since it's a blank piece of paper on the back, I would practice proving the quadratic formula, just like you will have to do on the back of the actual test. Does that make sense? So on the back of this page, I would write for yourself, given ax squared plus bx plus c equals 0, prove the quadratic form. Quadratic formula. Okay. I would do that again on the back of your test. Okay. All right. All right, back of your practice. You've got the rest of the period to work on this. You got about 10 minutes. You can get started here. No problem. There you go. One last thing, and for the folks at home and in here, I am going to be giving you this little half sheet of paper, and for the folks at home, I'll try to link this in somewhere. We're going to be having an extra credit assignment. Okay, I know I never give extra credit, but this is actually an extra credit assignment. Soon I am going to be putting my Chris math tree. See what I did there? Chris math. Like I got a list. Chris math. My Chris math tree in a little bit, like soon, like in like 2 minutes. And you guys can make me a math-related ornament for my tree. It's going to be bare. It's going to look like a Charlie Brown Christmas tree for a while until you guys start filling it up with math-related ornaments. It can relate to anything. You know, it can relate to Algebra 2. It can relate to geometry. Just got to be somehow mathematically related. And you've got to tell me how it's mathematically related. So these are the stipulations here. This holiday season, we will be celebrating the holiday of Christmas. If you would like to participate, you have the opportunity of receiving up to 5 bonus points. To get full credit, you need to create a math-related ornament for a tree, write a paragraph, at least 100 words. Don't freak out. This is 100 words. Not much. It's just enough to make you, show me how it's math-related. At least 100 words explaining why you chose what you made, how it relates to math, and anything interesting about your topic. No credit will be given without this portion. And then all ornaments are due no later than December 14th. That December 14th deadline is the Monday of exam week. The Monday of exam week. I want to do on the Monday so we can all sit and enjoy the tree for the week. Sound good? So, 5 bonus points. You could turn this in like tomorrow if you wanted to. Right? You could do this whenever you wanted, and I'll put it in the grade book already. So those of you like, ooh, my grade needs to come up really quickly. Yeah, I can put this grade in like ASAP if you want me to. Okay? But again, 5 bonus points. 5 bonus points. Okay. So long, folks at home. I'll see you later. Have a good day.